Hello, I'm Lacey Thompson. I serve as the news chief here at NASA's Stennis Space Center near Bay St. Louis, Mississippi. I'm standing not too far from the Fred Haise test stand. This is where NASA tests RS-25 engines to help power the SLS, or Space Launch System rocket, on Artemis missions back to the moon as we prepare for future journeys to Mars. I'm joined by one of our NASA test engineers and test conductors, Derek Zacher. Derek has agreed to answer some of the questions we've received during recent live stream broadcasts of RS-25 tests. Derek, thank you for joining us.
Happy to be here.
Before we get on to the questions, I'd like to ask you to share a little bit about yourself and how you became a test engineer and conductor here at NASA Stennis.
All right, well, got interested in aerospace as a child. I was more interested in the jet engines and aircraft than I was rockets and space. Went to school down at Embry-Riddle down in Daytona Beach, and that was close enough to Kennedy that I was able to go down and see a bunch of launches, and got really excited about it. Had an opportunity to come down here to Stennis, working for Orbital Sciences on their Antares program. And then when, after our first launch there, I was able to get a job here in NASA, working with the team here on the stand, testing the RS-25.
Thank you, Derek. We're so glad you're part of the NASA Stennis family. Now, let's get on to the questions. And the first question relates to an upcoming RS-25 test on the Fred Haise test stand. Somebody wants to know what the engine being tested is for, whether it's a new engine or a heritage space shuttle engine.
All right, this engine here is manufactured of all new components. It's part of our certification test series. What we did was we have about 12 engines left that are going to work through Artemis 2 through 4, and then we have to utilize new manufactured engines. So we are using new techniques for manufacturing, new materials that either weren't available at the time when these engines were first manufactured, or weren't suitable for the reusable aspects of the Space Shuttle main engine. So these tests are to verify that those changes don't impact the performance of the engine, and it still is suitable to meet our needs and is still reliable to get our astronauts safely into orbit.
And those new engines are being produced by the lead engines contractor, Aerojet Rocketdyne, is that correct?
Yes, sir, correct. All the components are manufactured out at their facility in California, and then they are shipped here to Stennis, where they are assembled and then brought over to the stand to be tested. And after we are finished testing them, when we get to the flight engines after testing, they will be sent down to Michoud Flight Facility outside of New Orleans, where they will be integrated into the next SLS core stage.
Well, thank you, Derek. Let's get on to the next question. And somebody wants to know what weather conditions permit a test. For instance, can you test during a thunderstorm?
All right, we can test pretty much any time. There are activities prior to the test that require our personnel to be outside doing setups and inspections. Obviously, they can't be outside during a thunderstorm for those. We have a lightning detection system on our facility that will alert us if there are lightning strikes within 5 to 10 miles, and in those situations, our people can't go outside. Down here in Mississippi, we're lucky that most of the time the weather comes here in the afternoon and the mornings are pretty clear. So when we know weather's coming in the afternoon, we'll try to pull all of the setups and all of the inspections forward in the count to try to get them out of the way before the weather comes in. We have backup generators that provide power, that in the event that we have a lightning strike that knocks out commercial power, we'll still have power to run all of our systems. And then in the event that in the last couple of minutes before a test, when we're trying to do our final inspections, if we can't send people outside to do those, most of the areas that we need to look at have adequate coverage via video camera that we can do an inspection that way. At the end of the day, though, what it comes down to is if the test director feels that it is the risk level has elevated to such a level that it's not acceptable, he can choose to scrub the test.
Well, that's great information, Derek. Thank you. Now, the next question is, how loud and powerful are these RS-25 tests? For instance, will they set off nearby car alarms?
All right, well, these are pretty loud tests. We don't allow too many people outside of enclosed structures close to the stand. But anybody within about 200 yards or so is wearing hearing protection because it's above our acceptable limits. I have never heard of a car alarm going off out here, but on that note, you know, we're a pretty secure area out here, so most people don't even lock their cars when they're out here, so they're probably not even armed. Now, I have heard some friends that live, you know, 15, 20 miles away from here that tell me that when the clouds are low and the weather is just right, they can actually hear us from, you know, 15, 20 miles away. So it is pretty loud.
Thanks, Derek. And of course, if the car alarm went off, you probably wouldn't hear it over the sound of the test.
Probably not.
So the next question we have is, how much thrust does the RS-25 engine produce?
All right, the RS-25 engine produces 470,000 pounds of thrust. That's vacuum rated, so that's at altitude. That's at 100% of the rated power level. Now, on the Fred Hayes stand, in preparation for Artemis missions, we are testing these engines to 113% of its rated power level. And at that setting, it produces approximately 530,000 pounds of thrust. To give you a little bit of idea of perspective here, that's about 15 times the combined thrust of the two engines on an F-22 fighter.
Thanks, Derek. Now, speaking about the thrust, someone wants to know, how hot and fast is the engine plume during a test?
All right. The gas coming out of the nozzle of the engine is at about 6,000 degrees Fahrenheit. It's moving at about a little over 14,000 feet per second, or over 9,000 miles per hour. The heat is so much that we use about 230 to 240,000 gallons per minute of water in our deflector to cool it and to keep the engine from damaging our facility.
Thanks, Derek. Now, some folks that have watched the engine test during the live stream, they've asked, what produces that cone of light you see right beneath the engine nozzle?
All right, that cone of light is called a shock diamond, or sometimes referred to as a mock diamond. What causes that is that when we're testing at sea level here, the engine nozzle is a little overexpanded because it's optimized for at altitude. What that causes is the pressure of the plume coming out of the nozzle is slightly lower than the atmospheric pressure around it. So as the atmospheric pressure interacts with the plume, it compresses it and straightens it back out instead of letting it continue to expand. This actually causes the velocities to reduce and the temperatures to increase. So right at that point where that diamond is, the temperatures are actually starting to ignite any residual fuel that's in the plume, and that's why it's visible in that area. If you watch, depending on what videos you see as you're watching it, you'll see that diamond moving in relation to the exit plane of the nozzle. And when that moves, that's when we are changing the power level of the engine. So the closer it is to the engine, the lower our power level is.
Thanks, Derek. That shows us that physics can sometimes be beautiful, because that is a lovely mock diamond to look at during a test.
Yes, sir, it is.
Now, the next question we have is, how much fuel is used during a typical RS-25 hot fire?
All right, Lacey, our propellant consumption on a typical test varies based off of our power level settings, so what our profile is looking at, and also the duration. Typically, for a normal profile, we're looking at about 6,500 gallons per minute of liquid oxygen and about 14,000 gallons per minute of liquid hydrogen. Our typical test is approximately 500 seconds. Sometimes you'll see us go a little longer, like our last test was 630 seconds. But we'll typically use about 55,000 gallons of liquid oxygen and about 140,000 gallons of liquid hydrogen during a normal 500-second test. We use an additional 8,000 gallons approximately of liquid oxygen to chill in our transfer line, our run ducts, and the engine prior to test. And we'll use about another 6,000 or 7,000 gallons of LH, or liquid hydrogen, to do the same on the fuel side of the system. Our run tanks aren't large enough to accomplish this, so what we'll do is we'll top off our fuel tanks prior to test, but then again, our even with that, our LOX tank is only 40,000 gallons and our LH tank is only 100,000 gallons. So we need to top off those tanks during test from our barges that you see docked at the side of the stands. We'll have separate people that operate those transfers to keep the test conductor free from having to worry about that. So we use a lot more than what you think just for what the engine's consuming, but we managed to make it work.
Thanks, Derek. Now we have a final question for the day. And most people, as they watch the test, they notice the large white cloud exiting the test stand. And somebody wants to know, is that plume, is that cloud safe?
Yes, that cloud is safe. It is primarily water vapor. So with the RS-25 engine operating on liquid oxygen and liquid hydrogen, when you combine those two elements, you get water. So you get water in a vaporized state, and then you mix that with the 200,000 gallons of water that's coming down the deflector that is being vaporized by that hot plume. And that's why the cloud is so big. It is almost all water vapor, and it's perfectly safe. As it cools, as it rises in the atmosphere and cools, it'll actually start raining, and we get a localized rain event right here on the facility, and it's perfectly fine if that water gets on you.
Well, thank you for joining us today, Derek. And that's all the time we have for questions on this broadcast. But if you have questions, we invite you to send them in so we can answer them on a future live stream. There is an email address on the screen now, and we'll be sharing that also during our live stream that's upcoming. We're approaching an RS-25 test right now. We thank you for joining us. Now, let's get ready to shake, rattle, and roar.